Alright, so looking at this next part of the year now. Alright, what I have here is the graphs, and in the next part now I need to transform each of the graphs so that they fit the new points which is given here. Okay, so what I'm going to do is bring equation by equation and see if I can transform each of these, and this will test my ability to do horizontal shifts and vertical shifts. Do I actually understand them? Okay, here we go. So I'm going to copy the first one. We can see this turning point could shift down by 1, 2, 3, 4, 5. 1, 2, 3. Oh, that's right. It's 1, 2 points. Right. Let's just block this out for now. All right. Now maybe let's go with another color. Black. Okay. So I want to get this graph to transform using translations. I could even use reflections if I needed to, by putting a negative in front of the a value and then flipping it over. So looking at this turning point, firstly, I can see that point over there, which is given by the equation -5 and -3. Right, that's my turning point. So my turning point is -5 and -3, which is over there. That can go from -5, it's got to get to -2, right? So -5 to -2, I have to plus 3 to get to -2. And to go from -3 on my y-axis to -5, I've got a -2 to get to -5. Okay, so if I change my new turning point to this, then the graph should work. Now I'm going to keep that one there in place, so I can go back to there if I need to. I'm going to paste another equation in here so that I can make this my working graph. So I got x plus 5. I want to change it into -2. Remember, it becomes +2 because the p-value changes into the opposite sign. And remember, the turning point for this equation here would become, this is y equals to a x minus p squared plus q, where that's p and q. So then y equals to a x plus 2 squared minus 5. And from here now, I need to find my a value, and we know how to find a values if we're given the other 2 points. We just got to substitute that point in there. And so we'll substitute -7 and 3 into this equation here. Okay, and see how far we can get here. Alright, so that gets me y equals to, let's see how far we can get to this here. So y, which is going to be, by the way, changing y into 3, because that's my y value, equals to a x is -7 plus 2 squared minus 5. I then plus 5 on both sides. I get 8 equals to a -7 plus 2 is -5 squared is 25, and I get a equals to 8 over 25. So that's the same as this here. So amazingly, all I need to do is just change the p and q, and this should work hopefully. So that's going to be q is going to be -5, so let's put a -5 in there. Alright, so I got +2 and -5, which is going to be those 2 values which I used, and a is 8 over 25. It's not actually reaching that point. You can see that it's short of the mark at the bottom, but that's because my domains have to change as well. My domain is now ending no longer at -5, it's now going all the way till -2, so let's change it to -2, and there we go, connected it. But my domain has to start from -7 as well, so -7 is my domain over there. Okay, so I got that equation, and I've got my domain. I've got to state all of these things in my answer. So remember, I've got PQ, which is my new turning point, which is going to become transformed, where I took the original P and I plus 3, and I took the Q and I minus 2, such that it ended up at the new turning point -2, -5. Okay. from the original, which was -5, -3. And so that's a transformation. What we can see from here is the whole graph has a horizontal shift. Okay, if I'm adding 3 onto this, I'm actually minusing 3 from here, if you can see that. Alright, so actually I'm taking the p-value, original p-value, minus p, which was going to be -5, and I am plusing 3, which works out. Okay. But we can see from here the turning point has a horizontal shift right and down. Okay. Are we going right? Right, horizontal shift is going to be right by 3 points, and vertical shift down by 2 units, or not points, let's use the word units in here. That'll be my turning point, and then I substitute the other point such that, and I double check this. I mean, it turned out to be 8/25, which is great, but it could not. I did this calculation anyway to prove that it does go through that, and the a value stays the same, but it might not always stay the same. Okay, so I now am happy with that transformed equation. It works, and I can remove this one here. I now go back and get my second equation and do the same thing. Copy the second equation, Control C, and then Control V, paste the second equation. I now need to get this to move. Remember, this is the initial point of inflection was over here. I want to move that point of inflection over here, in which case I'm going to change those 2 values over there into my new point of inflection. Okay, so let's make some notes on this as well. So my new point of inflection for this is going to be, I'm going to make this my new point of inflection is going to be -2 and -5, and remember the original graph was y equals a x minus p cubed plus q. P is going to be there, q is going to be there, so y will equal a x minus 2 becomes plus 2. Again, we're shifting it right down. Okay, and this is going to be cubed and down to the point of -5. Okay, and that is the equation. If I assume the a value to be exactly the same, maybe it'll work. Right, and then if that's the case, then I don't have to worry. I don't have to recalculate a. Let's say I did that and I assume that. So I'm going to copy this equation again here. That's going to be the original. I'm going to change this into the new model, which is now going to be 2 and -5, which is here. Okay. Also, my domain, you can see, is starting from -2, and it will release the rest of the line. That's what I want. And it turns out it's the same, in which case the a value at the moment looks exactly the same. A value is equal to 11/125, which is the same. How would we describe this? We can see it straightforward from the original graph that we have a horizontal shift of from where we were, which was initially from there to there. Okay, we're going to go 3 units to the right. Even though we're -3, we go, there's a horizontal shift right by 3 units, and vertical shift down by 2 units. And that would be the translations. We can mention that as well. These are translations that we want to have from here. My new domain is also changing, so stressing on the new domain or mentioning of the new domain in my notes would be important, and that is my new equation, which is a transformed equation from the other one. I can then release this equation and I'm done with that. Okay, I'd like to keep the color coding the same, so settings, go to this and make this red, press done, and that's all good. Let's go back again and substitute the next equation in here. And the next equation is this one over here. I could use this one here, which if I want to use +1 and -1 in my calculation. I'm gonna try this one here. I've got both of them there, depending which one I use. It's okay. I'm gonna plug in the original. Okay, there we go. I want to get that to go down there. I'm gonna change the color code again to another color here, green. Okay, so I'm gonna remember that this here is my hyperbola. And the hyperbola initially had asymptotes, which was running from -1 and +1 on this side here as well. Horizontal and vertical asymptotes part of the features, which I can mention. But I want to now change that so that it goes this way. By the looks of it, the starting point started at 0.8. It's now, to get to this point here, there is +3, or a horizontal shift of 3 units. And to go from 8 to 6, I've got a vertical shift. Down of 2 units. And so that would mean that if I repaste this over here, keeping it as the testing ground, remember that my x is my horizontal shift and always goes in the opposite direction. So if I want this point, just that point, to go right from 0 to 3, right? 0, 8 to 3, I'm going to +3, but over here I'm going to -3, which can become -2. So my original equation, which I had, will change. Let me see if I can just put it down here nicely. Alright, so writing this out neatly, I've got y equals to k over bx plus px minus p plus q. And I'm taking the p and the q value and I'm moving it, moving my central point, okay, by the same amount that this point has moved as well. So instead of having -1 as my asymptote, I'm going to have the number 2 as my asymptote for my p value. So in other words, when this is 2, that's going to be my new asymptote. And at the same time, if I look at it, I also want to make my lower asymptote -1. Alright, so lower asymptote, I want it to be -1. And that's going to be over here, which is -1 here. Alright, so that's the point over there. So we got 2, and we got -1. So y equals to k over bx minus p. Remember, it's bx minus 2 minus 1. And that's what happened as well with my transformation. I shifted it 2 units to the right from this point, just looking at the single point. Alright, 3 units to the right and 2 units down. That's the transformation. Horizontal shift right is what I got here. Alright, horizontal shift right. By 3 units, and vertical shift down by 2 units as well. Okay. And that's part of my transformation and how I would write it down. What happened to the p-value? The p-value, which was originally, we added 2, and the q-value we are minusing 1 from there. Okay, and that would be the transformation that took place from bracket to bracket. Okay. Alright, so let's put that in here and let's change this up. I'm going to keep the other values the same and see what happens. Maybe they weren't affected, in which case this would be -2, keeping my b value the same and making this -1. And also, if this still doesn't look like it's working, don't forget the domain hasn't been adjusted yet. So the domain should be adjusted. In this case, it should start from even if it starts from 0, it's got to end at 8. It's got to end at 8. It's actually going to be from 3 to 8. It's going to be from 3 until 8. Okay, so it's definitely falling short of the mark over there. You can see that, the original, which means we need to alter the k value and the b value. I'm doing this on a trial by trial basis as we go through it. Typing it in, checking it, typing it in, checking it. I could have done it in one go, which may have saved some time. So I got k over bx minus 2 minus 1. Now I want this to go through 2 points, remember that? So we got 8, 0 and 3, 6. That's what we want it to go through. So let's start with 3, 6. Okay, so if I substitute 3, 6 in here, then I gotta go 3 goes into x, 6 goes into y. 6 equals k over 3b minus 2 minus 1. That becomes 7 over k equals k over 3b minus 2. I now have an equation with b and k. I do the same thing again with the next one. I substitute 8 and 0. And this is x and y. So then 0 equals to k over 8b minus 2 minus 1. That becomes 1 equals k over 8b minus 2. Alright, so for these two equations I can use simultaneous equations and I can solve it. Is there an easier way to do this? Yes, there's lots of other parameters that can be used. I'm just jumping into this and seeing if I can get an equation that can transform to fit that. And so then if b and k changes, that means we've got to talk to that as well. We've got to talk to the horizontal stretches and compressions. We also got to look at the k value, which is the scale factor increase in it. And k is also multiplied by this fraction, so you can see it's some kind of vertical stretch as well, which k can produce. And the k value can be negative or positive. We could also flip it over the other way, or something on those lines. If we made it negative or positive, that could have changed it. I'm just looking at that now. But if we calculate this, this is my equation number 1 with k and b. This is equation number 2. In simultaneous equations, I'm going to move this across. I got 7 times 3b minus 2 is going to equal k, and 8b minus 2 is also equal to k. And so I can equate them. Remember, this is going to be 21b minus 14 is equal to 8b minus 2. 21 minus 8 will come to 13b. And then negative 2 plus 14 becomes 12. And so b will equal 12 over 13 for this. Okay, so that's my new b, 12 over 13. So that's going to be 12 over 13, which will go into b. And now to find k, I just got to use one of these equations. And my ability to use simultaneous equations, or solving simultaneous equations as well. Very important. And I then substituted in this. I got 8 multiplied by my b value, which is 12 over 13. That's going to be going into there. Minus 2 equals k. I can put it on a calculator. 8 times 12 is 96 over 13 minus 2, which is 26 over 13 equals k. 96 minus 26 is 70 over 13. Okay, and my k value will be 70 over 13. Let's check if that works in this equation. Yeah, changing this in here. I can make it look good later. This is 12 over 13. I'll put a bracket, 12 divided by 13, and close the bracket, so I know that's done. And then, or not, that's fine. And then at the top, I got 70 over 13. Okay, perfectly. Those 2 points meet. I can see that works out well. Simultaneous equations save the day there. My green equation seems like it's going over the mark there, or I don't know why it's there. Let's have a look at that for a second. I'm going to clear the screen here. And so the green equation, oh yeah, the green equation does not need to be there anymore. It's now being removed. We don't need it. We've now transformed it into that equation there. That equation can be neatened up. Okay, if I want to neaten up that equation, I'm going to use algebraic manipulation and fractions, which can be done at the end. But at the moment, it's a working model. It works quite well as a parabola, but I can definitely neaten it up. Okay. Alright, we'll neaten it up if we have some time on this video at the end. We're now going to transform the last part, okay, which is going to the last equation. I'm going to take that, which is my exponential equation, and I'm going to substitute. You could have used a sine graph, you could have used any graph you wanted to. Okay. Looking at the exponential graph, I want to transform it so that it looks like it's going to move down and right. Okay, so there's going to be some horizontal, vertical shifts down and right. Now, if you look at the original exponential function, we had a times b to the power of x minus p plus q, and those 2 points represented the vertical. This was horizontal in the opposite sign, remember that? So negative goes right, positive goes left, and this one here was my vertical translation, vertical shift, which is positive goes up and negative goes down. My equation that I have is 4 over 7, if I just move this out of the way. Okay, from here, alright, let's see if I can do that. Hold on. Okay, so we got this 4 over 7, where was I? Okay, let's go back here again. Ah, there we go. This was 3.5 to the power 1 over 5, because I couldn't find the root button. And it was all to the power of x, by the way. That's a power of x, even though it looks like it's right next to it. Okay, so if I take this and I look at my graph and I can see, let's say I take that point, I want to move it from negative 5 to 8. I can see that this is going to be a horizontal shift of, is it negative? Positive 5 to 8 will be plus 3. Okay, and I also need to go down. Once I've moved this way, I need to now move down from 2 to 0, in which case it will be minus 2 for me there. So I would want to utilize the negative down here, and I want to shift it right, so I would make it more negative on that side there. Then the original transformation of the point P there will be horizontal shifts. If I rewrite this equation and test it before I finalize it and put it into my written work, I've got x. I'm going to remember minus gets me the right motion, work rightwards, and I've got to go down, but it stays the same. So if I do that, okay, I could keep both equations. I'd like to keep both equations personally, because I can then see if there's any changes quite easily. So that's 2 to the power of x minus 3. And then, okay, so let's double check this out. Alright, it's not working out so well, so I'm going to rewrite it. Y equals to 4 over 7, just rewriting it again, to something which I'm going to put in there to the power of x minus 3. X minus 3, by the way, is at the top. Make sure your arrows move around if you need to. Minus 3. Oops. Then if it doesn't work, put it in a bracket. X minus 3, so you know it's stuck together. And then minus 2 afterwards. Okay. And if you really don't want to retype that, just Control C, Control V, and it looks like it works now. The domain, by the way, starts from 8 and goes to 13.5. So we're going from 8 until 13.5. Okay, and that means less than or equal to x, less than or equal to 13.5 for this one. Alright, which means I can then release this equation, release this one, and provide the transformed equation here. And how did I do that? I can talk to it horizontal shifts and vertical shifts. Oh, my domain, by the way, is not 13.5. It's just 13. Okay, there we go. And that fits perfectly. Now I've connected the new dots with new equations by doing actually mainly horizontal and vertical shifts. And I also make a note that I can come back to this equation and refine it by producing a common denominator here and dividing it and just simplifying that using algebra as well. Okay. If I want to do that quickly, just to show you if I did do that, this part here, let's do that quickly. So you can see the algebraic component of this part here. Here we go. So I've got 70 over 13 divided by 12 over 13x minus 2. Quickly work this out. 13 times 2 is 26. Denominator first. All over 13. All divided under 70 over 13. I'm going to bring this to the left. And I'm going to divide it by the bottom. And what happens when you divide a fraction by a fraction? It becomes 10 times, right? The left stays the same, the right flips over, 13s will cancel, and so I can rewrite this as 70 over 12x minus 26. And that would be a much nicer version of this over here. I'm going to put it here, and then we'll check if it works. If it does work, then I'm going to remove the other one because it's more neater. 70 over 12x minus 26. We generally don't like fractions in there, but it does work. If you have time, it will be good to make sure that you get that done. 3 less than or equal to x less than or equal to 8. Closing the bracket over there and then clearing it up here. Okay, and let's get this out of the way and check if it's all good. I'm going to deactivate this one. Yeah, it's all good, everything's connected. This was the hyperbola, this was that one, and now we don't need it, so I'm going to remove it there. Okay, and that's the transform version. We can talk to it as well from the previous one as well. Another thing here is that the actual motion here, remember the horizontal shift that takes place from this here is 26 over 12 to the right. Because if you make 12x minus 26 equal to 0 and you solve it, x will equal that, and that would be the right motion because it's positive. Because it's negative, actually x equal to 12, because it's negative over here, it'll be moving right as well. Okay, so, but anyway, that would just present you with the asymptotes. So this is actually not the motion, this is just a new asymptote. As a side thought, just so you know. If it was without the 12 and just x minus 26, then the asymptote will be at 26, but not 26 over 12, which changes.